quero tchá, tchá, tchu, quando o DJ tocar. Pra você fiz lelê, mas tem uma nova onda que agora vai bombar depois do
Object number in simulation is better equivalent to PLC output number. In previous lecture, we're talking about it's better to use the same number as the Y output number. To be object number. So whenever Y, how many drive mechanism, then we know immediately what objects has to be drive. Together with cartoon chart, it's very easy to write or edit visual script. In this concept, we prepared a file named CSV file YF7 new. According to the cartoon chart, the S1 only single output Y1. So in YF7 new, the first control station only one object, Y1, object 1. For S2, the P2 CC file, the P2, the second station, we have Y4 and Y5. In here, you can see Y4, X5.X is object 4. Y5, X6.X is object 5. End of second station. The rest, object 3 to 1, just the feeding org.x, a very small dummy X5, and the show O0, not show. So this is P2 CC file. P2, the second station. The S3, third station, only Y7 and Y8. So you can see here Y7 S9.x is object 7, and the Y8 X10.x, Y10 is the 8th object. The rest, object 6, 5, 4, 3, 1, 2, 1, all feeding org.x, and all not show. This is P3 object, P3 S3, and for S4 only Y2, Y3. the y2 object 2, y2 s3 point x object 2, y3 s4 point x, y3 object 3. Only object 1 feeding org.x, not a thing. As to S5, P5 CC, the fifth station, only Y6 and Y9. You can see Y6 object 6, Y9 object 9. The object 8, 7 feeding org.x, not a thing. The object 5, 4, 3, 2, 1 feeding org.x, all not a thing. The P6, no change. The end of P6, S6. As to the seventh station, the seventh station is for the assembly of the out filter with Y14, Y15, Y16 and Y19, Y20, Y21. So Y21 is here, Y21 object 21, Y20 object 20, Y19 object 19, 18, 17 feeding org.x, not a thing. Y16 object 16, Y15 object 15, Y14 object 14. The 13, 12, 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, all feeding org.x, all not a thing. As to S8 and S9, only 2 and 2 here's. We just lay it only object 1 and 2, since the CC file already settled. So just keep P6, P8 CC file and the P9 CC file as its original. Now we try to correct the CC file. The P2 内牙补料 CC file, P3 内牙补料 CC file, and the P4 备料减值 CC file, and the P5 内牙组装 CC file, as well as P7 套管组装 CC file to be altered right now. Okay, let's close the new file, yf7new.csv, and go back to CMS CAPP and reset to stop the PLC in automation running, and use new to remove the old scene file and use scene input name of scene. Adopt the file we just showing, this one, yf7 new. Open this file. Okay, then we start to alter the visual script from P2 CC. P2 CC is the 内牙补料 see it in more detail. Okay. Then let's go to the teach more, and the S2 is P2, so the number 2 control system, and load CC from CMS GAC data, find the P2 CC file. The CC file is P2 内牙补料, or the P2 on the left side. Let's find P2 内牙补料. Okay, open this file. We change the K26, only the object number, the same as the Y output number, and then save it. After save it, we doing the run to see the simulation. Okay, the first instructions, K21, input number 2 shut, because this is second stations. As this one activated, the first instructions has to close the input 2. Then the second instructions, K20, Y4 activated. Let's see the carton chart. S2 in here. Y2 actuated is this one activated. This one thrust in. What is this? This is cutting cylinder to break the top, and this one to separate this one as a single supplier. So Y4 thrust in to break, to isolate this one. As this one thrusts in, there is no input sensor, limit sensor. And K21, the Y5 shut. The Y5 shut, just move back to the home positions. So these single parts will drop in positions, waiting for inner parts assembly with the aluminum pipe. Okay, let's see the K26 3D simulation. Use K26 this pipe inclined 45 degrees. So as this one thrusts in, it will move along X a distance and along Z a distance, the same distance to make the 45 slope. Also gonna thrust in the position. So here K26 X15 Z15, this object number should be number 4, and the K21 shut Y5, the simulation is K26 back to 0 positions. The object number should be 5. Okay, let's change these two lights. This one change to 4. This one change to 5. Okay, then let's see next one. As this stress in, this return back one job. After one job, we have to fill in this one. How to fill in this one? This one in, this one out. Then the top will from the slope down one to here. Okay, this one has to shut in first. What is this one? This one is Y5. Y5 thrust in. So K20 Y5 open. So object 5 will thrust in. And this one retract back shut Y4. K21 shut Y4. Okay, the actual simulation. K26 as 5 thrust in. This should be object 5. The X move for 15. The Z move 15. And the shut Y4. The simulation should be K26 0 0 0. Here is should be 4. Okay, let's change first. This one 2 change to 5. Object 5. And this one change to object 4. So object 5 thrust in. Object 4 back to home position. So this space, according to this plate, retract. So the top inner tapping parts will fall in one to fill in this space. And then this one will touch input 6. This retract back will touch input 5. So K23 waiting for input 5 and waiting for input 6 become 1. So K32 input 5, K32 input 6. That's it, the end of P2 CC5. Okay, then we save the CC file as P2 内压补料。P2 内压补料 CC file, save it. Okay, before we run to see visually, we have to understand at the last this one thrust in. If we don't give a waiting time, in no moment this way one will return back to the home positions. So it's better as doing the simulations at a single run. We have to set delays. Suppose 5 seconds. Now you can see at the last line, adding K22, 5 seconds. We add K22 5 seconds after saving the CC file. Then we can run to see The expect action is this one in, this one out, one in the tapping piece drop down to this location, the V-shape supporter. After that, this one in, the leading cylinder is tend to thrust in to prevent the rest dropping down to this area, and the cutting cylinder retreat. Then one internal tapping piece will drop, filling in this vacant space, and the rest as well. And as we run, this one at the end, this one in, this one out, and waiting for 5 seconds, this one out as well. Okay, let's run to see the show. Go in, and this one 5 seconds retreat. Okay, fine. Let's see again. Reset, clear the lights first. Okay, this in, this out. 5 seconds, this out as well. Okay, go. Five seconds, go. So the P2 CC5 work okay. Then let's go to change the number 3 control system. Then we turn. To this location. You can see from here. Okay, this is cutting cylinder, this is leading cylinder. This is upper, this is lower. Then number 3 control system, renew, low CC5, P3 内压补料 P3 内压补料 .cc, open it. The first one still K21, input 3 off, shut. Then K20 Y7 actuated. Let's see the carton chart. P3, the cutting cylinder thrust in first, while K21 Y8, the Y8 shut, retreat back, and this retreat back, this thrust in, no input sensor. The actual movements is K26 X go 15, Z go 50 millimeters. This one should be object 7, and this retreat back for Y8 K26 retreat back to 0, 0, 0 positions. This one should be 8. So let's do the change. Object 7. Object number 8. Number 8 equivalent to Y8. Easy to remember. And there's no K32 waiting for any input. So as this one in, this one out, the single in betweens will falling down the V-shaped supporter. Then this one thrust in, this one return back, filling the space. Okay. This one in. K20 object Y8 actuated. This one in. And this one out. The cutting cylinder out. Shut. K21. The Y7 shut. And let's see the weighting. This one in. Input 10. This one out. Input 9 will become 1. Then the moving will stop. So 9 and 10. K32. Not waiting 9 input. K32 waiting 10 input. So for this one, this K20 Y8 actuated, the movement is K26. It should be K26 X15 Z15. So this one, the line 9 will become line 8. The object should be 8. And this one at the real, the Y7 shut. K26 back to 0 positions. This one should be 7. So this 2 has to change position. So let's go to here, modify. This one should be object 8. The X going 15 millimeters. The Z going 15 millimeters. That's it. The next lines, the object 7 back home. Home is SYZ 0. And the end of this P3 CC file. Let's check again. Let's go back. Okay. K20 Y8 K26 15 Z15 object 8 K21 Y7 shut K26 back to 0 object 7. Okay, then save CC P3 内牙谱料到的 CC file. After save P3 内牙谱料 CC, then run for the simulation. The same, we set delays 5 seconds at the real. As run the action, we expect to see this one in first, this one return. Drop the single parts on the V-shape supporter. And then this one in, the leading cylinder thrust in, and the cutting cylinder retract back to fit in the parts in between here, and waiting for 5 seconds. The leading cylinder will retract back. Okay, let's run. In 5 seconds, this one retract back. Okay, at the last, this one in, the Y8 lights is on. Okay, reset. Let's go again. Run in, back. 5 seconds back. Okay, the P3 内牙补料 CC5. Okay, then we go to number 4, control system. Use renew to clear the data buffer and low CC. P4 备料减资 CC5, just this one. And let's see, change position. To see the movements. This one is P4 action. Let's see the cartoon. S4, Y2, Y3, Y2 to for this one. This one is cutting cylinder. Y3 is leaving cylinder. This is Y4, Y3 driven piece. This is Y2 driven piece. Okay, let's see the program. The same K21 input 4 shut. Next one K20, the Y3 actuated. Y3 actuated, the leaving play thrust in, while K21 Y2 shut. This one retrieve back. The parts falling down from the 45 degrees slope, drop 1 in between Y2 and Y3. So Y3 thrust in has to wait input 4. Y2 retrieve back has to wait for input 3. Let's see the waiting first. K20 32 waiting for input 3. The line number 7, K32 waiting for input 4. Okay, 3 and 4, 3 and 4. And let's see the simulations. K26. The K26 has the leaving play thrust in. .45 slope. The object 3 in here has to go along x positive direction 30 millimeters, along z direction positive direction 30 millimeters. As K21 shut Y2, the K26 back to 00 positions. Object 2 should be here. So let's change 3 and 2. This one, object number 3. This one, object number 2. That's it. After waiting 3 and 4, then we will let this one drop in here, waiting for inner tapping piece assembly. How to let this one drop? First, we have to activate Y2 cutting plate. Let a single one isolate the single one here, and then retract Y3. Let the single one drop down. That's it. So you see the K20 Y2 activate Y2, so the cutting plate will thrust in to cut single one in this space, and the K21 Y3 and this one retract back, so the single one will drop in. There isn't any input sensor. Okay, let's see K26 simulation. For this one, thrust in K26 X30 Y and Z S30. This one should be object 2. This is Y3 shot. The simulation is K26 back to 00 positions. The object number should be 3. So let's change. This one become 2. Object 2. This one become object 3. After that, the P4 备料减值 seems okay, and alloy bar located at the first teeth, supported by this teeth and this teeth. Hot line number 12 and 13.4. The K20 input 1 is used to actuate the S1. What is S1? S1 is this one. Push the horizontal plate to let one alloy bar falling to the slope, and K20 input 5, what is for, which is to be used to actuate P5 CC5. What is P5 CC5? Is for inner tapping piece assembly, just in this location. So after P4 CC5, which will actuate 2 CC5. The first is P1 CC5. Next is P5 CC5. Okay, let's save the P4 备料减值 CC. Save P4 备料减值 CC. Save it. Then the same will do the simulation. The last one is this out, this in. This thrust in, this is retract back. We have to wait for 5 seconds to see this one still in high position until 5 seconds, retract back. We can add at the wheel, but there are 2 waiting input. the suitable positions just in front of K20 input 1. How to insert one waiting time? Just use insert here and use modify. The K number give 22. The X space filling 5 means 5 seconds. K22, K5, input 5, waiting 5 seconds. Okay, let's see. Let's see the first, the lower plate thrust in. This one stay. Actually, it's retrieve back, but already in home, so it's just stay there. The second step is this one in to cut the rest on the slope and leave single one, isolate single one in this space, and this object object 3 will return to home positions, and let this single aluminum bar falling down the first teeth. Okay, reset. Let's go. Right. The lower thrust in first. This one return back. Then the cutting plate thrust in. The leaving plate retract. And wait 5 seconds. The cutting plate retract back again. Okay, let's see. 5 seconds. The cutting plate will return to home positions. And 1 and 5 on. These two will accurate P1 CC5 and P5 CC5. Okay, reset. Let's see. Last time. Wrong. 5 seconds. Accurate P1 and P5. Okay. The number 4 CC CS control P4 备料减脂到的 CC check OK. Then we continue to do number 5 control system. Renew load CC P5 内牙组装 CC5 for here. The first instructions K21 cross input 5 and K20 Y6 on, K20 Y9 on. Let's see the join S5. The Y6 on, push the cylinder. The Y9 on, push the cylinder for assembly. As pushed, waiting for input 8 and input 12. Let's see the K32 first. K32 waiting for input 8, K32 waiting for input 12. While the PLC K20 Y6, the simulation is K26 Y minus hundreds, and this one should be object 6. while K20 accurate Y9. The simulation is K26. This side along Y positive direction 100 millimeters. This one should be object 9. Okay, let's change it. Six in here, 9 in here. So this for accurating. For assembly, after assembly, the 6 and the 9 should be shut by using K21. Shut Y6, K21, shut Y9. The simulations, K26 back to 00, object 6, and the K26 000, object 9. Okay, let's change. This is object 6. This is object 9. And waiting for input 7 and 11. Let's see, correct or not. As thrust in, return back, waiting for input 7 and input 11. Waiting for input 7 and input 11. Okay, this is for retrieve back. After retrieve back, then we need to fill in the space, one at the right, another at the left, and waiting for next assembly. How to fill in? The supply has to rate P2, S2 actuated, and the P3, S3 actuated to fill in these two. So in here you can see K20, the 2 actuated, S2, P2 actuated, and then K20, input 3, S3, P3 actuated. For supplier, each one at the both end. That's it. This is the CC file of P5 内压组装. Then let's save CC P5 内压组装. Save it. Then doing simulation. The simulation has to be we don't need to add any weighting because the piston push out and then return back, not stay in position. If in position, then we have to rate the position, keep the position for 5 seconds to show the movements. Okay, we can run to see the piston going out and return back. On purpose, we let it show on here. The moving distance can be adjusted at the physical machines. By adjust the sensor. In CMS CAPP, we can adjust the distance. 100 millimeters can be altered to 110 millimeters or to 90 millimeters, depends on needed. Okay, let's run. Go. You can see Alt and return back. Let's see it again. Alt and return back again. Okay, fine. So the P5 CC5. Okay, the last one is P7 CC5. Let's change to number 7 control system and renew. Load CC. Search P7 套关组装，开启旧档。The first line still K21 input 7 and K20 15 be activated. Let's see the cartoon chart. At S7 there are Y14, 15, 16 and at the left side 19, Y20, Y21. These two for support, this one for push the cylinder of the out feeders for assembly. Totally is 6 output. So let's see the first one, K20 15, Y15 in, actuated. The lower holder move up along Z positive direction, and the K20 Y20 is the left holders move up a distance, and the Y16 and the Y21 actuated. The holder will moving down a fixed distance to create two turnots in both sides as the piston thrusts the outfitters through the tunnel for assemble the aluminum pipe fixed on both sides of the aluminum pipe in accuracy. So K20 Y16 K20 Y21 Y16 Y21, these 4 be actuated. The movements K26, this one should change to 15 objects, moving down 21.5 millimeters. And this should be object 20, not moving down, moving up. This is at left button. The holder is at the left button, moving up 21.5 millimeters. So this one should be 16. This is the holders at the right top, moving down minus 35.5 millimeters. And this one object should be 21. The left top top holder moving down minus 35.5. Okay. Let's correct the wrong object number. From the first one here, the right button holder, this one should be object 15. Next, the left button holder, so this one should be object number 20, and this one, the right top holder, this one should be changed to object number 16, and this one, the left top holder, should be changed to object number 21. Let's check again. Fifteen, 20, 16, 21. Okay, both side holders moving, simulation okay, and after move we have to check the sensor. Let's see what sensor we have to wait. As this move in, we have to wait sensor input 23, this one up waiting for 32, 23, 32, and this moving down waiting for 26, this one waiting for 34. Okay, 32 input 26, and okay, 32 waiting for 34. So this waiting is okay. After two terminals created on both sides of the aluminum pipe, then we'll thrust in for the assemble. K20, Y14, and K20, Y19. As 14, 19 actuated, the assemble to push the piece here through the tunnel to fit on the terminal of the aluminum pipe. So both sides all together. After push, waiting for input 22 and input 30. Waiting for 22 and waiting for 30. Okay, that's okay. Then we see the simulations for K20, Y14. So the simulation is K26, Y minus 160 millimeters. This one should be 14, and this one K26 going up 160 millimeters along y direction. This should be object 19. So let's change it. This one 14. This one 19. Waiting. Okay. Then retract. In here, before retract, K21 8, open S8, activate P8 to supply 1 for next assemble. It's better to cancel these two lights to move to the rear after the bar coming back to home positions. Then to open, activate P8 and the P9. So these two lights cancel. How to do it? Right now it's at 9:20. Just press delete. Then this light be cancelled. The same in here, K20 input 9. Just press delete. Then these two lights be removed. Okay. Right now K21 14 retract. The right side retract. K21 19. The left side retract. The K26 back to 00. Here should be 14. K26 back to 00. This one should be 19. Okay, let's change it. This one 14. This one 19. And then waiting for input 21 and 29. That's C. 21, 29. Okay, 21, 29. Okay, no problem. And then release the holder. Just back home positions. Use shut K21. Shut Y16, the up right holder first. K21 shut Y21, the up left holder next. K21 Y15, the button right third. The K21 Y20, the button left next. The action all back to 00 positions. The K29 K26 for simulations. This one should be object 16, the top right cover. So this one should be 16. Next one, the top left cover should be 21 object. The next one, the right button cover should be 15, object 15. the left button cover should be object 20. Okay, let's check first from the top. Object 16, object 16 back to 0. Y21, object 21 next back to 0. Y15, object 15 back to 0. Y20, object 20 back to 0. After both ends, the holder retract back, we still have to wait for the input value. Retract back has to wait for input 25. Here waiting for input 33, and this one waiting for input 24. Okay, 32. Okay, input 24. The last one is waiting for input 31. Okay, 32 waiting for input 31. That's it. This is the end of P7 CC5. After the end, then we have to save CC, save P7 套管组装 CC5. That's it. Then we can run the data to see the simulations in here. Okay, run this hole to create two terminal and thrust in to see a distance. Thrust in. You can see here we'll extend on purpose. We laid these parts in front of the surface. You can see this piece show its head, and then we track back. Okay, run. Hold, thrust in, and return back, and open. Then let's see it again. Go. Last time. Okay, fine. P7, the last one, ending. Then we have the whole 9 from S1 till S9. The 9 CC file correct. Then we can run automatically in PLC mode. And during the simulations to show the ending strings on the screen. Okay, let's go. PLC mode. From the beginning. Renew. PLC mode. Activated. Go.
Cheguei na balada doidinho pra habilitar. A galera tá no clima todo.